Hi Year 12, today we're looking at z-scores. So we can transform any normal distribution into a standard normal distribution by using z-scores. So to convert a raw score, x, into a z-score, we use the formula z equals x minus mu, which is x minus the mean, over standard deviation. So this is where mu is the mean and our sigma is the standard deviation of the distribution. So for our examples, we have a data set is normally distributed with a mean of 15 and a standard deviation of 2. And what we want to do is we want to draw a probability density function for this distribution. It's also important to note that the z-score formula is on your reference sheet, so you do not need to remember this formula. And it is on page 2 above the normal distribution graph. So on our normal distribution, we're going to put our mean where 0 would be, which is at the maximum point. So our mean was 15. And then we're going to go up 1 standard deviation. So add 2 to 15 to get 17, then 19, 21. And we'll do the same going down. So 13, 11, 9. We're then going to use z-scores to convert each x value to a standardized score. So our z-score formula is z equals x minus mu over our standard deviation. So our z will equal our x score of 19 minus, for this one, our mean was 15 and our standard deviation is 2. So when we put this into our calculator, 19 minus 15 is 4. 4 divided by 2 is, in fact, 2. So that means our z-score equals 2. We then have x equals 15. So again, we use the exact same z-score formula. Just going to copy that down here. Exact same z-score formula. So we'll have z equals our x of 15 minus our mean of 15 divided by 2. Divided by 2, which 15 divided by 15 is in fact 0. So 0 divided by 2 is 0. So therefore our z-score equals 0. And then for 9, we have our z-score formula of z equals x minus our mean over our standard deviation. So z equals 9 minus 15 over our standard deviation of 2. 9 minus 15 is negative 6 over 2. So this equals negative 3. So therefore we have a z-score equal to negative 3. Then our next example, we have a data set is normally distributed with a mean of 23.8 and a standard deviation of 1.2. We want to find the z-score for each raw score and describe where it is on a standard normal distribution. So we'll use our z-score formula of z equals x minus the mean over the standard deviation. So we'll have z equals 25.7 minus our mean is 23.8 over our standard deviation of 1.2. When we put this into our calculator, what we get is 1.538. Oh, 1583 repeater. So what this is, it lies, we'll just round that up to 1.58. So now we want to describe where it is on the standard, on a standard normal distribution. So that means that a score of 25.7 lies 1.58 standard deviations above the mean. That's what our z-score is saying. Okay, for 20.6, we have our z-score formula of z equals our x minus our mean over our standard deviation. So z equals 20.6 minus our mean of 23.8 divided by our standard deviation of 1.2. So when we put this into our calculator, we get 20.6 minus 23.8 over 1.2. We get minus 2.67, 6 repeater. So this will equal negative 2.67. And so what this means is that a score of 20.6 lies 2.67 standard deviations below the mean. For 28.3, same process again. So we substitute in our x. So z equals our x of 28.3 minus our mean of 23.8 over our standard deviation of 1.2. So we get z equals 28.3, 3.75. So a score of 28.3 lies 3.75 standard deviations above the mean. Okay, so now we want to know which of the scores from part A are very unlikely. So we're going to draw our scores from part A on here. So this is our mean of 0, our minus 1, minus 2, minus 3, 1, 2, 3. So our Z scores go on here. So our first Z score was at 1.58. So that's roughly here, 1.58. Then we had our negative 2.67. So that was here. And our last one was 3.75. So the score that's very unlikely is the Z score of 3.75 because it's actually outside 3 standard deviations of the mean. So generally all the scores are quite closely grouped together. So Z score of 3.75 is unlikely. Generally they're between minus 3 and 3, and the closer to the mean they are, the more likely they are. Is unlikely. Therefore, a score of 28.3 is very unlikely. And finally, C, find the value of a raw score whose Z score is negative 1.82, correct to two decimal places. So for this, we use our Z formula, so Z equals X minus mu over our sigma, or our standard deviation. So we know our Z score is minus 1.82. X is what we're trying to find. We don't know this. We do know that our mean is 23.8 because this is continuing on with this question, and we know our standard deviation to be 1.2. So we're now just solving for X. So we multiply both sides by 1.2. So minus 1.82 times 1.2 gets us negative 2.184 equals X minus 23.8. We then plus 23.8 to both sides to get X to equal 21.616. So X equals 21.62 to 2 decimal places. So the raw score is 21.62.